Recitation problem 1. The displacement vectors A and B, when added together, give the resultant vector R, so that R equals A plus B. Use the data in the drawing to find the magnitude R of the resultant vector and the angle theta that it makes with the positive x-axis. How do we handle vectors? Of course, by means of components. The starting point is the addition of A plus B. R is going to equal A plus B. Whatever you do, never add vectors at this point in time. You start plugging in numbers once you have put together the components. Okay, the components for A and B are very easy in this case. Vector A first. Since the A vector is parallel to the Y, therefore its x component is going to be 0. Any vector that is parallel to the Y has 0 x component. Any vector that is parallel to the x has 0 y component. The y component for A, however, is the entire amount of A. The only thing that you need to be careful with is the sign of that vector or that component. Positive in this case because it's pointing straight up towards the positive y, 6.0 meters. The vector B needs to be broken into two components. The two components, basically you start at the tail of vector B and you make your way towards the tip of B, making a right triangle in the process. Here are the Bx and the By components. Notice that the Bx is positive, the By is pointing straight down negative. We're going to use the 23-degree angle to solve for those two components. Bx is adjacent to the angle, therefore Bx is going to equal, since it's positive, here's my positive sign, B cosine 23. By is going to be, notice it's negative, therefore here's the negative sign, B, that one took the cosine, the other one automatically going to take the sine, 23. Since the B is equal to 8, therefore this one is going to be 8 cosine 23, and this one is going to be negative 8 sine 23. Once you evaluate the components for your vectors, all you need to do, take your equation, the R equal A plus B, break it into components. Here is the x component first. Rx is going to equal AX plus BX. The Rx is going to be, what's the AX? 0, right here. The BX, as stated here, it's 8 cosine 23. Therefore, the Rx equals 7.4 meters. In a similar way, we can solve for the y component. Y, R of y is going to equal A of y plus B of y. Alright, substituting for the A of y, which equals 6.0, plus the B of y, notice, is negative 8.0 sine 23. Solving for the R of y, we obtain 2.9 meters. Once you know the x component and the y component of any vector, you should be able to solve for the magnitude of that vector. R is going to equal Pythagorean theorem, R of x squared, R of y squared. Putting the information together, you solve for the R, you get 7.9 meters. To solve for the angle, basically all you need to do, the inverse tangent of the y component, because they want us to figure out the angle made with the x-axis, it's got to be the y component over the x component. Solving for the theta, we obtain an angle of 21 degrees. To be more precise, the angle 21 degrees is 21 degrees above the positive x-axis. Notice that the x component is positive, the y component is also positive. What does it mean? It means your vector has the following direction. The two components for that vector are like this: x component positive, and also the y component is this way, positive. If the two components are positive, you are in this particular direction. In our case, the way we need to describe it is 21 degrees above the positive x-axis.